Okay, the next example is when you want to solve for the plus c. So you're just finding what we call a particular solution to a differential equation. Remember that it's just called a differential equation because it involves a derivative. So you still do the same thing. You integrate both sides. So the integral of the derivative is just y. The integral of e to the x is e to the x. The integral of negative x, or negative 6x squared, add 1 to the power, divide by the new power, and then you also need to include the plus c. But now you're given a point. We often call this an initial value because it's just some point on the original function, and we're going to use this point to pin down the function, find the plus c, or find what the c value is. So we're going to take this 0 and plug it in for y, plug 1 in for x, and then solve for c. So it ends up that, if you solve this, before we get the c alone, you end up with 2 minus e equals c. You can leave it like that, that's fine. It's not a pretty number, but it's a number. So your final answer to the equation should be, when you write this equation, this original value of, original function, as a function of x with the c value determined. Oops, that's an e. So this, in the last example, this represented whatever y looks like. It doesn't look like that, but it just represents that c this c represents some, vertical translation of this graph. But here, that we found the value of c, it pins down the function. So if we know that there is the point 1, 0, then my function must, pass through this point. So the vertical translation is determined. We call this an initial value problem, just because you're given an initial value that you can use to find the plus c.